mean, that's actually, in retrospect, of course, BSD is. Yeah. Okay, so yeah, I mean, thanks. That was what I determined to do through budget taking. So, because nobody writes anything down, of course. Yeah, I'm sorry. It was unwise of me to say close it because I knew nothing about BSD and macOS was a different. Thanks.
Talking about ECN and macOS.
Yes. UP ECN reporting socket options. Not terribly consistently. They've all ended across platforms. It's definitely not documented anymore.
So Linux does it in my opinion, strange way.
Right.
So on a V6 socket, for example, V4 addresses are reported in the V6 syntax of a map address.
Where
So on BSDs, when you say you want to receive the T class, and you get it, it reports the toss byte as a T class.
So in fact, really should probably do something that will kill the socket in macOS and BSD.
No, it will not. It will report a it will report
return an error.
Inval.
Which
Inval, okay.
Which generally, well, in Chrome will kill the socket, which is why macOS was seeing
enormous.
Was seeing a bunch of TCP failovers in Chrome.
Nice. Okay.
So, I mean, you shouldn't fail the communication because the socket option fails.
Yeah, I mean, it's just the way our code works. I mean, I could have been more discriminating about.
Yeah, we have a number of error cases that are kind of like that's fine.
Yeah.
Like, and then a few. I think unreachable. We still kill the connection for.
But
for example,
I'm glad I killed it because we would never have discovered this otherwise. So it actually worked out well. I just hope like nobody fixes the bug in Linux, so then Chrome's going to win.
I mean, what could possibly go wrong with? I hope no one fixes the bug.
Yeah, I don't know if it's a bug because there's documentation. Maybe it's the way it's supposed to work. What feature is this? This is reporting ECN on UDP on a dual stack socket. You have to configure IPv4, IPv6 TLS separately as a socket.
For Linux, you need to issue an IP proto level socket option on an IPv6 socket.
Yeah,
it's the right comment. No, we fail that. No, it's wrong. We just do the right thing when you issue the V6 option. Okay, I think we should. Hello, this is TCPM. So if you're not interested in TCP, you might be in the wrong room. My name is Michael Turkson.
Ian Sweat.
And Yossi.
We are the co-chairs, and this is the notewell, which you should have seen already. And basically, we have a JavaScript, but we need a note taker. So, anyone willing to take notes? Thank you, Siad. You will use the note taker tool?
I'll do the shared document.
Perfect. So, if you want to submit documents which are addressed to this working group, please include TCPM in the name, then it shows up on our radar. And as you know, this session will be recorded. That's our agenda for today. We have, I think, more time than needed. We asked for 19 minutes, we got 120, so we have no time problem. We'll talk about the working group status first, then we have 3 working group items. PRR, Neil will report about the latest changes. Accurate ECN, Richard and Bob are not here, and Mirja is just joining the room, but I'm channeling the slides which will document the differences in the last 2 revisions. And we have a presentation about the accurate request. At the end, we have presentation about an individual document, which is related to the presentation we saw at the last IETF regarding Ghost X. And these are the documents we are working on. The green one is the one which is in the RFC editor queue, and it's now actually not there because of a misref, but now it's actually the RFC editor is working on it. For the blue ones, we have presentations in this meeting. The 2 black ones, generalized ECN, we don't have a presentation. This is tied to the accurate ECN. Once we have shipped the accurate ECN document to the to the AD, we'll start the last call on the generalized ECN. We don't have a presentation on TCP EDO, but we have a presentation about the accurate request. And I left in the document the dates from the milestones. And at the last meeting between the chairs and the responsible AD, the question was brought up by the AD what we want to do with the milestones. So do we want to keep dates there and update them, or don't we need the dates? As the working group, I mean, what I observed in the past is that we normally run late on the milestones, and pretty often we just update the milestones to a later date when we have a better thinking of when the document will be finished. But there's the possibility to not use dates there. Has the working group any opinion on keeping dates, not using dates?
Gory fair who can't work out the tool to get in the queue, but yeah, do something that works. I mean, I do like the dates, but I think the dates have to be realistic, not retrospective. That's totally stupid. And you have to work carefully with your editors to give a real date. And when they don't make it, you have to kind of revise it. That's okay, but this is rather silly as it currently stands. Does that help? No. Okay. So I say I like them. I say please do realistic dates and tell us when you think things will be.
I mean, we try to do realistic dates. I haven't intentionally not updated them because.
So actually, yeah, Gory, why do you like this?
I like this because it tells me what I should be reading on my reading list and whether this is actually making progress. So that's why I like it. But I mean, I just follow the mailing list and wait for you to ask.
So I wanted to say the opposite. I think like this has no benefit for this group. I don't think it would change anything in this group, how we work. So I think we can get rid of it.
Do you have an opinion?
Oh. Ian Sweat as an individual. I agree with Miriam that it probably won't change anything whatsoever. It's also a little bit annoying to have dates that are obviously like fantastical, and it seems like this is not a problem specific to our working group. So like, I think this goes back to my general principle of like, I think trying to keep dates up to date in the IETF has generally been like an enormous failure. And so like either like we should try to figure out a way to keep them up to date, like literally at the beginning of every meeting, like force us to update them in the first like 3 minutes of the meeting, or just give up on them entirely. I'm kind of inclined to give them up on them entirely, but yeah.
Just use the mic.
Yeah, thank you. Mia Kulevent here. Now I'm in the queue. So if the goal is realistic milestones and you look at the history of this specific group, you have to update them all to show like whatever 2035 or something, then we're good, right? I don't know, I'm joking. But like you have to, it's not enough to just say, oh, we didn't reach the milestone, we should bump it by 3 months. It's like, if you want to do realistic milestones, then actually figure out like what's realistic.
So we tried to use realistic milestones. We failed. And I think it's good we failed. I mean, I think it's good that we took the time to continue working on the document. What I have a bad feeling is by inserting milestones is that people maybe not knowing how this working group works, expect the document to be finished by that amount of time, and then they get disappointed. And so I personally think we failed in the past so often to give a precise deadline that we shouldn't do this. However, I'm partly with Gori, trying to get some information about what's next, or what is kind of a sequence information. And I think we can keep the milestones in a sequence where we think, this is the sequence we are working on the documents, or this is the sequence we will deliver them to the ISG. And I find that important information. So that might be a compromise between providing the information we are pretty certain that we can fulfill the expectations and not giving any expectations we are not sure on.
Matt Mathis. I would actually wish that the milestones showed a different field, which is what was the date that the document was most recently updated? So I can scan it and say who's making who looks like they're making progress.
Hello, Alan Jarrett. I'm wondering if we just want to put a sequence number in the docs saying this is the order in which we expect them to be finalized rather than date.
I mean, that could be the sequence of how we are listing them.
Gary Fairhurst, I can work with dates, I can work with an order, but knowing which one's coming up first for you guys is important. And it's important when I point other people to groups in the IETF to say, this is what they're going to do next. Other people outside the IETF don't have a clue about the dates, but they do have a kind of wanting to know which ones of these are nearly finished.
Matt, are you still in the queue? Oh.
I joined the queue newly, Mirja Kulevent here. I don't understand actually why we have an order, because these are all independent documents and they might take a different time to get finished. And when it's finished, we should ship it. That's it.
That's true. But for example, a generalized ECN was serialized behind that. And from my view, PRR is much more advanced than TCP EDO is. So we have some partial ordering. Anyone else? Yoshi?
I don't have a specific opinion about milestone, but I want to mention about EDO draft. Is it okay if I talk about EDO draft a little bit right now?
Sure.
Okay, so I think we have discussed this draft intentionally in the past. Right now, it's a little bit quiet for a while. I think back then, one weak point of this draft was there was no implementation. But recently, the Kunyuki from AWS implement EDO option, and then he presents a very nice implementation report, and then some updates, some proposal to update draft, and then Joe seems to be agree on it. So I'm thinking that this might be a good chance to finalize EDO document. And so I just would like to get feedback if people, think it's a good time to finish it, or people think it's not, we don't have to work on this one anymore. If you have any opinions, I would like to hear. If there is no opinion, I just send a message to the mailing list and check the opinion from the mailing list.
Okay. Then we take that from the mailing list. Any other questions, agenda bashing? If not, then we are moving on to the first presentation, which will be Neil on PRR. Hi, Neil. Will you run your slides or?
Oh, should I? Let's see. Which button is it? Ask slides. Is that the button?
Try it.
Okay. Let's see. Hello.
I see it twice.
I don't see where I pick the slides. Maybe you guys should show the slides. I don't see the.
Oh.
Nice. Here you go, Neil.
Ah, there we go. Okay. Okay. Great. Yeah. Okay. Yeah. So thanks. Thanks everybody. So I'm going to give an update on the proportional rate reduction draft. This is joint work, obviously, with Matt and Nandita and Yuchang. So just a refresher and some context for folks. So RFC 6937 was the proportional rate reduction for TCP draft. This was published back in 2013 as an experimental RFC. And at the time, it was only implemented by Linux. And it was implemented without rack TLP because that didn't exist yet. And PRR, you can basically think of it as kind of a mini congestion control that runs during fast recovery. And the high level idea is to send packets where your current sending rate is proportional to the delivery rate. And the proportion is chosen by the congestion control algorithm, where with Reno it's 0.5 and with Cubic it's 0.7. And the idea is that that proportion is set so that you smoothly reduce the amount of data in flight with that ratio given by the target, given by congestion control, and the multiplicative decrease made by congestion control. And if the amount of in-flight data drops below the SS thresh, then there are two different modes of behavior you could use it back in that spec. One is a slow start style behavior, and one is a packet conservation behavior. And in the original RFC, the implementation needed to pick which option it used. And I just sort of as an interesting fun fact, for a flow that mostly operates in fast recovery, its congestion window in practice is mostly controlled by the PRR behavior instead of the core congestion control behavior. And this happens quite often in police video stream flows using Cubic or Reno, for example. All right, so the 6937 BIS effort was motivated by the fact that we've accumulated 10 years, 11 years now, I guess, or even 12 years of experience since RFC 6937. And this effort started in 2021. And at this point, PRR is default enabled in most of the major TCP stacks, including Linux, FreeBSD, Microsoft TCP. And so the TCPM group voted to revise and publish the PRR draft as a standards track RFC. And in the slides there, you can find the link to the current version of the draft. So we've discussed in previous talks a number of revisions since 6937. Some of them were algorithm refinements. Probably the biggest one was sort of automatically choosing between the two different modes of increase when in-flight is below SS thresh, based on a simple but effective heuristic. The second one is to specify or clarify that when you're entering fast recovery, you want to make sure that you force a fast retransmit, even if the normal computation wouldn't allow it. There's also a little more information about how to support non-SAC connections. And we also wanted to be more precise or about how we handle the case where there's higher network reordering, which could cause a connection to wait for many packets to be SACed before it enters fast recovery. We also wanted to make some editorial clarifications, and which we don't need to go into. And then also we removed the experiments section that was in the original RFC. So for this most recent update to the draft, we pushed in the past week, and most of the changes were in response to various detailed comments from Marku on the TCPM list. And thank you, Marku, for the comments. I guess he's maybe not on the call now, but maybe he'll watch the video. Thank you. They were very thoughtful and very detailed, and they highlighted a number of issues that we think we've incorporated all of Marku's feedback into the draft. And we responded on the mailing list about how we think we've incorporated that. And then there's a link to the diff if you want to see exactly what changed, but then I'm about to give a sort of summary of the major changes. So the first major change was to clarify that PRR triggers its initialization based on the start of the congestion control slowdown or reduction rather than the start of loss recovery. And the main motivation here was that the congestion control algorithm within a given loss recovery episode, congestion control might actually decide to make several reductions in its sending rate, that is several reductions of SS thresh. And for the behavior to make sense, each of those reductions in SS thresh would need to reinitialize the PRR state machine so that you get the correct behavior. So we just wanted to clarify that. So the new text basically says, at the beginning of a congestion control response episode, that's when we initialize the PRR state. And the timing of that response is basically entirely up to the congestion control algorithm. And we give an example where the congestion control might decide to make multiplicative decreases for every round trip in which there is packet loss, even if you're still recovering the same sequence range in fast recovery. All right. The next change was about the initialization of the recover FS variable. So in this rev, we no longer use pipe to initialize that. I believe Marco pointed out that pipe can be incorrect if there's a spurious loss detection decision. If there's reordering that is initially interpreted as loss, then that can cause pipe to fall below the value it should have. And then those packets that you marked as lost might then later show up and actually be delivered, which could then cause the arithmetic to work out badly, and you would end up sending too much. So instead of using pipe, we use a different approach. We also make sure in this revision to incorporate data that was selectively acknowledged before entering recovery, because there can be, for example, if you have an algorithm like rack TLP, which sort of adaptively estimates how much reordering there is in the path, then you might end up in a situation where you actually have quite a lot of data that's selectively acknowledged before you enter recovery. And if you want the math to work out well, then you want to factor that in. And then in addition, the new math incorporates data that was cumulatively acknowledged upon entering fast recovery. This is probably a rare corner case that would only happen if acts are lost or things like that. But we may as well cover it because actually in fact, in implementations, it's kind of actually simpler and easier just to incorporate that. So the new text basically, it makes a more precise definition of recover FS in the text, which I won't read. And then it refines the pseudocode to be like the pseudocode here, where you basically start by setting recover FS to the entire sequence range from send next to send UNA. But then we subtract out the bytes that were sacked before entering recovery, because those will never be marked as delivered during recovery because we already marked them as delivered. And then we also want to include this rare but simple case where when we're entering recovery, there might actually be some amount of data that's being cumulatively act on that acknowledgement. So that's the detail there. The next change was in the specification of delivered data, which is the amount of cumulatively or selectively acknowledged data that has been noted on the processing of this act that we're handling. And there, Marco pointed out that we had some bugs in the pseudocode. And so what we've proposed to do basically is to go back to the prose definition that we had from the RFC 6937, and we just removed the buggy pseudocode. So here is the prose definition of delivered data. It's basically the same as 6937, except that we've added a note about misbehaving receivers, where they could potentially decide to try to trick you by sending lots of dupacks, more dupacks than is really appropriate, in which case you want to watch out for that and not use those dupacks if you know there are too many. Yeah, so that's the delivered data change. And then the final major change was the clarification that or specification that PRR should set the congestion window to SS thresh when it's finishing a PRR episode. This was not in the RFC 6937, but it's actually something that the Linux TCP implementation has done from the get-go in 2011. And there are cases, depending on the loss patterns and depending on how you set SS thresh, there are cases where this can be really critical for good performance. So we thought, since it can be important for performance and there's more than a decade of experience, we thought we'd go ahead and put that as part of the standard. Marco was concerned about the potential for bursts, so we did want to mention that is a possibility. Just like 6675 can cause bursts, PRR can cause bursts in some cases. And so we recommended if you're concerned about that, then you should be using pacing. And so you can see the new text around this. Basically, we say at the end of a PRR episode, you should set CWIN to SS thresh. And we note that that can cause bursts, and that if folks are concerned about that, which is totally reasonable and a good thing to be concerned about, then we recommend you use pacing. I mean, we also mentioned that this is not the only thing in TCP by far, by a long shot, that can cause bursts. There are much more common things like restarting from idle within an RTO that can cause big bursts. But in any case, like the other causes of bursts, this one can be mitigated with pacing. And then we fixed some bugs in the examples. That those were due just to the fact that the SS thresh calculation was incorporating the data sent in limited transmit. And Marku pointed out that the RFCs say that shouldn't be done. And so the examples just needed to have their SS thresh reduced from 11 to 10. And then you just need to sort of work through the details and make the small adjustments in the examples to make those work out. So there are the details there. And then the final issue was that folks have pointed out on the list that there were some research papers that where people have noticed in some experiments where because Linux TCP currently and for a while has been using PRR to do CWIN reductions in RFC 3168 ECN, there can be poor interactions with at least some ECN AQMs, where you end up with, because of the CWIN reduction is very gradual, depending on how the AQM responds to queue length changes, depending on the details there, you can have an extra round trip of ECN signals from the AQM if there's a poor interaction. So we wanted to incorporate the reference to that since folks had pointed that out on the list. And I think that's the final issue. So chairs, where would you like to take it from here? Are there any questions I guess we should ask first?
Yeah, thank you. I did have one clarifying question, Neil, if you wouldn't mind going back a few slides.
Yeah, which one?
Use this one. Yes, the pacing one. So I agree with this recommendation as an individual, or probably as chair as well. But do we have normative text in other RFCs besides obviously like RFC 9002 that recommends pacing when restarting from idle? Or is this kind of though it's well practiced, sort of a new recommendation that broadly applies to TCP?
That's a good question. I don't know. There are probably other people in the room who are more familiar with the other standards and whether they recommend pacing. I feel like maybe one of Gory's drafts about how to handle application limited behavior may have mentioned recommending pacing. I can't remember.
Okay, thanks. Again, I have no concerns about this text whatsoever. I just wanted the working group to be aware that it's sort of adding a much more broader recommendation for pacing than I necessarily was aware of on the TCP RFCs. Gory.
I was good. Maybe the RFCs I wrote say that, it would sound likely. I think the IW increase document says if you're bigger than that, do this, which is kind of the precedent for doing this in TCPM, and I do agree. I think it's a good thing to write.
Yeah, thanks, Gory.
Alessandro Ghedini, Cloudflare. We have implemented a version of this for our quick stack, but that was like a while ago. We haven't done the work yet to update to the latest drafts. That said, I looked at the changes. They look fine, but I wonder, do you know if any of the other implementations like Linux or FreeBSD needed any, fixes for updates to the draft, or the updates to the draft actually came because of bug fixes in the other implementations? So
the The algorithm here has been implemented in Linux TCP for a number of years. I could go look it up, but I think it's been exactly like this for maybe 2 or 3 years at this point. And I think it's been qualitatively like this for maybe 8 years. But the details of the heuristic to choose between when to slow start and when not, those details changed 2 or 3 years ago, but the qualitative behavior has been the same, I think, since about 2015.
Okay, thank you.
There is one other person in the queue who actually requested to present slides. Was that an error? Or did... Okay. I am going to refuse the slide request, but if you'd like to put yourself back in the queue, feel free. Okay.
Any other comments? Yashi, you are the document shepherd.
Yeah.
Do you have
So, yeah, so I think we have been discussing this for a long time, and then Mark gave very nice feedback, and then I think in the current draft, I think the draft addressed most of the comments that Mark's raised. Yeah, I think it's the current shape of the draft is fine from my point of view. So I'm thinking that it's ready to go to submit IETF, IESD, sorry. And so I think even if the Mark is not satisfied with the current versions, he can have a chance to comment during the last call. So I think it's okay.
Sorry to interrupt. I just want to clarify I heard you right. Did you say it is now ready to go or not ready to go?
Oh, sorry. I said it's ready to go.
So not ready.
Now it's now to ready to go.
Okay, thank you. Sorry.
Sorry for my bad pronunciation.
It's not just me. The auto transcription said not ready as well.
Okay.
Last second, triggered by Alessandro, right? So if people are implementing this for Quick, and this is obviously TCPM, right? Do we need another document? Do we need to move the document? Is it implementable as is for Quick? I'm sort of, now that we're in this new world where it's this other working group, right, that's supposed to do the generic, general style congestion control stuff, we always have to sort of figure out where stuff should live.
I mean, it's not just this, even like implementing cubic, the way that the RFC is specified is different to how the Quick, recovery and congestion control algorithms. You need to do some work to sort of convert them, but.
Yes, so I'm one of the authors on cubic, and we realize we do need to probably have how do you do cubic for Quick correctly? That notwithstanding, this might be another one of these, right? So.
Yes, as an individual who implemented this probably like 6 or 7 years ago, not the exact current version, but yeah, what was standard then, it's a bit tricky to kind of infer everything from the documentation and stuff, but it's honestly not as bad as you might fear, because there's a number of things in Quick that I think make it a bit easier. The question of process as to whether we want to add a section on Quick to this or a future version of this document, or do something in the congestion control working group, I'm inclined to infer to like an AD or some other individual, but
not here, but this is kind of my fault, so I'll say something anyway.
Yeah, I was going to say, I think you have appropriate opinions at the very least, Martin.
So I mean, obviously this document was grandfathered into the. Sorry, yes, thank you. Grandparented into the into TCPM because it was already here, even though it could have been a CCWG one. So I think there are like a bunch of options. One is like no one cares enough to do anything about writing it for Quick, in which case nothing will happen. If we just care about Quick, we could just do like the shorter possible document in Quick working group to port this stuff over, with presumably heavily referencing this one. A third option is to just add a Quick section here and just run it by people. And if we want to make this general to all transport protocols, which there probably is not energy for, we could do it in CCWG. That sort of sidecar document, if we want to put it in SCTP or whatever, but I'm skeptical of that. I'll stay here, but.
Lars,
I got again. So yeah, between your options, so that I was gonna say something similar. If it's a, page of text that says, here's how you might do this in Quick, I think it kind of makes sense to do it in this working group, and maybe you do a joint last call with CCWG. And if it's more complicated, if it's several pages, then we're probably talking about a separate document. But if it's a little thing, right, it's like for Cubic or for this one, maybe we get a section, maybe we get some quick people to look at whether this makes sense, and then we'll ship it here. And it can obviously update like whatever needs to be updated over on the quick side. I guess 9002 would be the one.
Matt Mathis, speaking as an author. We're tired. Please just call it done.
Gori Fairhurst now has to try and implement this in Quick. No, it's nearly all there in Quick, isn't it? I mean, the base Quick spec says refer to the old version of PRR. So we write a new version of PRR. I mean, at least we should somehow update that Quick spec to say point at this one, perhaps. And if you could add a few paragraphs or something to say how to do it and where the pitfalls are, that would be wonderful. But another document to do that? Well, yeah, that's fun, but maybe not what we should be doing. I mean, this has been around for ages. I'm saying, please add a little bit, if you can, to tell us how to do it in Quick from experience and ship. Updating things if you think the AD needs to.
As an individual, I would say this is probably less than a page of text to add text about Quick. If it's more than that, then I think we're probably doing something wrong. As a chair, I sympathize with Matt's point. I'd like to see this shipped. I think if we're going to add a Quick section, I want to time bound that and be like, if someone doesn't come up with text in like 2 months, like your time has passed, you become a pumpkin, and you will have to
So right. So
move on.
In that vein, first of all, Neil, your keyboarding is coming through the mic, so please mute.
Oh, sorry. Okay.
Secondly, yeah, I think the operative question is who's willing to figure out and then write Quick text. And if like the answer is nobody, then I think we have our answer. So I don't know if you want to ask for a volunteer.
That is what I wanted to do. So who is willing to look at this and at least say there is text needed or there is no text needed? I'm not requesting for someone now saying that he will write or she will write the text which is needed, but just give us an indication, a timely indication, whether this needs Quick specific text or not.
I would do it with help, like Sandra or someone else. Like ideally, help with someone like yourself who's written this for Quick before. Like I do think some text would be helpful, just based on what I know already, and of reading the draft. So, but if it wasn't there, I mean, the world wouldn't end. So, but I'd rather have a partner partially because it's just hard going back and forth on text by yourself is impossible.
So I have a process question. Where are we relative to last calls? Does this still need both a working group last call and an IETF last call?
So it hasn't shipped to the ISG yet, and I think I'm looking at Yoshi. We are past working group last call.
So we are going to submit ISG. So this is a phase of working group last call, not the last call.
So we are considered to have passed working group last call, and next step is to ship it to the IETF.
So if I remember correctly, we had a working group last call. We got comments from Marco after that. That's what we have. That has been changed. So if we now get some additional Quick text, we might run another short working group last call and then ship it.
Okay, so I think what I'm hearing is that we've opted for option 2, which is Alessandro and Ian have a time boxed commitment to write some Quick text, and poor Matt here doesn't have to do anything because he's tired. And then like either it happens or it doesn't happen, and then we do a second WGLC. I can live with that.
I mean, if we have quick specific text in, we can always ping the quick working group for a joint last call, something like that. Any more comments?
Queue is not empty, but
Yeah. Yoshi, did you have anything else to add?
I just have a very, not related to process question, but a technical question about the scope of the draft. So some people think about expanding to this quick, and then but in case of quick, many implementation is BBR, and then in case of BBR, then BBR has a pacing mechanism. But from my point of view, PRR is the congestion control for act-driven congestion control. So from my point of view, I'm not sure if we can apply PRR to BBR. That's my naive question.
Right, that's a good question. So it is not intended that PRR be applied to BBR. If people think that's worth adding to the draft, we can definitely do that.
So, I mean, we implement PRR specifically for Reno and Cubic and not BBR. I don't know that would it be useful for BBR?
So translated literally, I don't think it's a good idea for BBR. But the BBR V1 design for handling loss recovery is very similar to PRR, super similar to PRR actually. So I don't think we need to worry about trying to port it over for now. So if folks think maybe it would make sense to basically say that to make some statement about the scope of congestion controls that for which PRR is expected to be useful, and say it's expected to be useful if you have an SS thresh and you have and it's known to be useful for Reno and Cubic, something like that.
I'm sorry, I might have just missed it. So does this document apply to, as written, currently apply to both Cubic and Reno?
Yes, it's intended to.
Okay, super. Yeah, I'd want to make Matt storm out of the room to say, like, what about other congestion controls? Lovely, thanks.
From a procedural point of view, I would also prefer that the PRR document does not depend on BBR procedure-wise.
Okay, Gori first. Yeah, quick 9002 has 6937 as an informational reference. So that's one where there is a dependency. BBR, please don't, because we need another document for that, even if it's short. This is not the right place to do that.
So point of clarification, do you guys mean, do people think it's worth clarifying that, like mentioning BBR to clarify that this is not intended to apply to BBR, or should we just not mention BBR at all?
I'd suggest just not mentioning it. It opens a can of worms. And we probably will make a document in this space sometime in the future when we know what to do.
Yeah, I agree that it's probably more useful to have a section to say where it applies, like which kind of congestion control. And I believe the answer might be simple. If you have a multiplicative decrease, it makes sense.
Thanks, Mira. I was going to say something similar.
Okay. Any more comments, questions?
I just would like to confirm that if anybody opposed to submit this one to IESG, please speak up. This is a good chance for you. Seems to be no one.
updates.
Sure. The-
I think we're done with that.
Yes.
So
Okay.
then, thank you. The next one is accurate ECN.
Are you under that?
Can you run the slides?
Yep, that's why I was confused.
Accurate ECN. Bob and Richard are not here. Mirja is here, but I'm channeling the update. Next slide. At the last IETF, we were actually in the situation of the document is done. I looked at this one time again, and there was one issue, and the issue I sent to the mailing list was there's a section about offload support or implications on offloading TCP. And it was written in the using the term TSO, transmission offload, something like this. But the text was actually only talking about the receive side. And I looked at the send side of offloading, and I played a bit with NICs from Intel and looked at the driver specifications. And it works basically that the software provides a large TCP segment with an IP header and a TCP header and the TCP payload. And then the hardware breaks it up into multiple IP packets. It copies over the IP header, it copies over the TCP header, it splits up the payload. And it does some mapping with the TCP flags. So the fin and the push flag only goes in the last segment. And the CWR flag goes on the first, at least on Intel cards. And if you do accurate ECN, you don't want that the CWR bit is modified. So it's part of the 3 bits counters, and it should be copied over to every segment. And on Intel cards, you can actually configure maps. So you can say on the first segment, which of the TCP flags should go there, for the middle segments, which should go there, and for the last segments, which should go there. Which means you can configure whether the TSO works for classic ECN, or you can even change the config for Intel cards. You can change the configuration to do exactly what's expected by accurate ECN. You don't do this per connection or per packet you pass down. It's a global modification. I have no idea whether this is configurable on cards by other vendors. So I'm not making a statement there. I just realized that there might be a problem with some vendors, and problem means that you need to do something in the software or in the configuration if you use classic ECN or accurate ECN. And this was not covered in the text. Next slide. And so I said, please either make explicit that your description is only about the receive path, or mention something about the send path. And unfortunately, there was no feedback by the authors between the last IETF and I think 2 weeks ago. So that's why it took a while. There is now text in which describes the situation and makes people aware that they have to consider this if they are using accurate ECN and in combination with TSO, which at least is for some people, it's an important factor to reduce the CPU load. you have different options. So you can possibly just ignore it and don't provide packets with TSO enabled when they are critical, and then you reduce the amount of packets you can use TSO for, or you could focus on one of the other, configure your NIC in that mode, and don't do the other version. That's also possible. So there are ways forward. This is not a blocking point, but it's a point you need to address. That was the last issue I'm aware of as a document shepherd. Any further comments on this document?
Stuart Cheshire from Apple. I reviewed this document last weekend. I sent an email about it, which I actually wrote on the plane, but I forgot to click send, so I realized I hadn't sent it at the start of this meeting. So that's in the email, but I'll repeat it here as well because I think it's important. This document has been in the works for almost 10 years. It's implemented in macOS and iOS. It's required for L4S. And I'm really impressed with this document. I'm impressed with how much work went into it. If this had been in TCP from the start, it would just be one page. And instead, it's one page of spec and 71 pages of forwards-backwards compatibility negotiation, dealing with TSO, dealing with middle boxes, dealing with buggy implementations. I don't know whether they missed anything, but I couldn't see anything that they missed. So it's really thorough. It's needed. If we still have Neil Cardwell on the call, he might be able to comment because he's probably better informed than I am. My understanding is accurate ECN is not yet in Linux mainline for the good reason that the Linux maintainers don't want to throw in every random idea that comes along. They want to see IETF consensus before they put something in the Linux kernel, and I understand that. So we're in this situation now where Comcast is rolling out, Comcast is doing trials of L4S, and I think soon to be launching it for 60 million customers. Apple has Prague for Quick and coming soon for TCP. We're making huge progress, and the Linux service in the data center have become the bottleneck that's preventing all of this. So I would love us in this working group. I mean, it's been through working group last call, maybe more than once. I think it's time to publish this. And let me know what I can do to help make that happen.
Thank you. Mirja?
Yeah, I just wanted to say there is ongoing work to bring this into the Linux mainline, and I think having an RC would only help that work.
Yes. So as I said, it was already, I mean, it was almost finished at the last IETF. So I have the Shepherd write-up on my hard disk, and it will basically say that there is consensus in the working group except for one person, which is some of the issues we couldn't address, but it's one person, and there is a way to avoid the problems the person is bringing up that will be documented in the Shepherd write-up, and that has been agreed with the AD. So the document will be shipped with this caveat. From remote, any comments, or if not, then we can move on.
Thank you.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP ACK RAID request tar option. My co-author is John Crowcroft from the University of Cambridge. So first of all, a quick reminder on the motivation for the draft. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead However, it may also contribute to suboptimal performance in a number of scenarios, such as so-called large congestion window scenarios, meaning when the congestion window size is much greater than the MSS. In that case, saving more than one of every 2 acts may help improve performance, or small congestion window scenarios, meaning a congestion window size up to the order of 1 MSS, where delayed acts may incur too much delay or may limit congestion window growth, and so on. Next, please. So this is the main format for the option. The R field indicates the ACK rate, which is requested by the sender, meaning after how many received data segments the receiver should send an ACK. And then there's the special case of R equal to 0, which indicates the request of an immediate ACK while keeping the steady state R. Next, please. So today I'm presenting version 05, which aims to address comments received in the last IETF. And actually the main comment was, are we going to make something in the network very unhappy because of tar? And that was in the context of the presence of elements that aim to modify the ACK rate between the 2 communicating endpoints. Next, please. So in order to try to address this point, we have first added Appendix C, where we aim to analyze which is the impact of tar in the presence of such elements that modify the ACK rate. So first of all, we start by discussing ACK filtering and ACK decimation. So ACK filtering is a technique by which there may be several ACKs from the same connection between 2 endpoints stored in a queue, perhaps at the receiver, perhaps in some middle element between the 2 endpoints. And in this technique, the older ACKs may be removed. So our understanding is that despite the presence of tar, there will still be at least 1 ACK per congestion window of data, and therefore we don't see any particular problem or any obvious damage that tar would incur here. So, however, there's ACK decimation where ACKs are dropped, but with less control over which ones are dropped. So in this case, ACK decimation may drop all the ACKs that correspond to a congestion window of data, producing a retransmission timer expiration. And in fact, if we use tar with an ACK rate greater than 2, it may contribute to this problem because it will reduce the number of ACKs that will be sent by the receiver. So here we would propose a rather conservative solution, which would be that upon retransmission timer expiration, the sender in this case would request the receiver to revert to normal delayed ACKs operation in this case. Next, please. So we also present receiver-side aggregation, such as LRO in the appendix. We explain that it may reduce also the number of ACKs. In this case, tar using a request of R greater than 2 may also further reduce the number of ACKs, may contribute to the same problem of not eliciting at least 1 ACK per congestion window of data, leading to retransmission timer expiration. And we understand that the same proposed solution would apply, meaning that the sender would request the receiver to revert to delayed ACKs in that case. Next, please. So for this reason, we have added some text in section 3.1, which describes the sender behavior, which is as follows. When the sender knows that the receiver is tar capable and the last ACK rate requested has been greater than 2, upon retransmission timer expiration, then the segment carrying retransmitted data must carry a tar option with R equal to 2. So we would expect this measure to request the receiver to revert to delayed ACKs. So next, please. Yeah, so that's it. I don't know if there may be comments or questions. Yes, Neil?
Yeah, so the so upon RTO, the idea would be to say to use a tar value of 2 with, and I guess, can you remind me, that means every other packet, is that right?
Sorry, can you, I didn't hear well.
So was the recommendation that upon retransmission timeout, the data sender is asking the data receiver to acknowledge every other packet, like every 2 packets? Is that right?
Yeah, I realized that, double thinking after the draft was submitted, maybe there's another way to try to produce the effect of reverting to tar-less operation on the receiver. But, well, requesting R equal to 2, in principle, should also produce the same effect, because in the draft, we are also saying that the receiver, in any case, as in the normal base main TCP specification, an ACK must not be delayed for more than, 0.5 seconds. But perhaps there's a cleaner way to do that, which would be using, for instance, one of the bits in the format of the option. There's one reserved bit. Also, we might even steal one of the bits from the R field to signal the receiver that, yeah, maybe instead of doing it in this way, to just signal, okay, stop using tar.
I guess my concern that I wanted to mention was that when you have a retransmission timeout, the standards and most of the implementations set the congestion window to 1. And so if you then send 1 packet and you're asking the receiver to only acknowledge every other packet, then the receiver is going to give you a delayed ACK, which might cause 200 milliseconds of extra latency. And so if we're going to go to the trouble of having an explicit signal asking the receiver to optimize their ACK behavior, I would suggest that when you have a retransmission timeout, for the first packet that you send, you ask for an immediate acknowledgement, which I guess maybe is the tar R value of 1 or something. And then as you increase your congestion window, you could, maybe gradually increase the R value or something. But I was just going to encourage the text to be sensitive to that fact that after retransmission timeout, usually the C window is 1. And so if you use R equals 2, you're probably going to invite 200 milliseconds of latency when you didn't need to.
Okay, thank you. Yeah, so we'll take this into account. Okay.
Yoshi?
I just simple comment to address the Neil's comment. I think it would be easy to create a new draft that said initial window is 2. That is, I think, a more straightforward solution from my point of view.
We had a bit of a hard time hearing you. Unfortunately, the audio in the room is not always clear, especially for the chairs. Could you repeat that, Yoshi?
Okay. Yeah, I prefer setting initial window 2 rather than 1. That might be a good solution for the issue that Neil raised.
So am I correct in saying that you'd like the text to say something like, say like the minimum of either 2 or the current congestion window after retransmission timeout?
Right.
Okay, that makes sense. Yeah, that's kind of, I would agree that's a sensible approach. The goal would be that after retransmission timeout, you would always ensure an immediate ACK and then make that happen.
So Gori first, just encouraging that. That also gives you a timestamp because it gives you an RTT measurement. I mean, getting it to respond immediately after an RTO sounds a good thing. You look puzzled. I shall talk slowly. I think doing R equals 0 or R equals 1 after an RTO is a good thing because you get an immediate feedback, you get a new time measurement. Maybe the time was wrong, maybe that's why you got an RTO. So this is good practice to do that. Maybe even good practice after a few packets and then go back to 2. I mean, you figure this out.
Okay, thank you.
Any further comments?
Thank you.
So the next presentation is about ghost eggs, and the presenter is remote. It's Peng.
Hello, everyone. My name is Yepeng Ban. I'm going to give a presentation regarding our recently submitted internet drafts, which concerns the TCP handling of out-of-window package to mitigate a problem we call ghost stack. So in the link here, you could find the current internet drafts. Okay, go to the next page. Yep. So here is a list of what is covered in the presentation. So first, overall, our internet draft focuses on the ACK number validation for established TCP connections. And we aim to solve a problem that allows segments with out-of-window ACK numbers to be accepted. And we call these ACK numbers as ghost ACK. So first, I will provide a review of the current RFC, and then a definition of the ghost ACK problem. Then it's the proposed solution in our drafts. And then it's finally the implementation status of operating systems. So as of now, RFC 993 specifies the ACK number validation for TCP and for incoming segments for established TCP connection, we need to check both the sequence number and ACK number for the incoming segments. Because the internet draft is mainly focused on the ACK validation, so I will only cover the ACK number validation here. For ACK value, we reject the segments if the segment's ACK value is after the send next, which is the next byte to be sent by the server. This is because we should never acknowledge, let's say client acknowledge something the server has never sent. So the current standards allow a server to accept anything before send next, which also covers old ACK values before send acknowledged. Send acknowledged is the first byte to be sent, but not yet acknowledged. And so it means we could also accept old ACK values before this point. And in principle, this allows a range of 2 giga sequence number to be acknowledged by the peer. Sorry, next slide. So the current RFC allows the basic RFC allows a large range of several ACK numbers, and this allows a TCP injection attack to find a several ACK number in 2 attempts. RFC 5961 proposed to apply a stricter check for acceptable ACK numbers, which try to mitigate the TCP injection problem. So the condition is updated a bit. The right-hand side is still the package cannot acknowledge something that is after the next. But in the left-hand side, we also limit the old ACK number cannot be too old within the range of max send window. Yeah, can you please go next slide? So, but unfortunately, even with the 2 standards after RFC 5961, it's still possible that an attacker could acknowledge something out of the window, and we call this as ghost stack. This happens for newly established TCP connections when there is no data, only few bytes transferred. As you can see in the plot here, if we have a newly established connection, then we have send acknowledge equal to send next equal to the ISIN number plus 1. So at this point, any sequence number before the server initial sequence number are not used by the server, but according to the RFC 5961 specification or the RFC 9293 specification, these old ACK numbers before the server ISIN number are considered as acceptable. And this allows a TCP injection attack or TCP spoofing attack to inject payloads into a new TCP connection, or it might accidentally accept a missing or deletes TCP segments in previous connections. So our internet drafts concern this problem and want to mitigate it. Next slide. So in the internet drafts, we provide two implementation choice. The first one is generic, and it doesn't require any RFC recommendation to be implemented by the TCP stack. And in the summit internet draft, the formula shows on this slide is only from the current internet draft. Based on some comments from Michael, we believe there are some conditions we could optimize, and we are going to update them in the next revision. But as for now, I will only introduce what is on the draft. So to implement the mitigation, we need to add a new state variable known as a check for established TCP connections. And this basically tracking whether the connection is possible to the ghost arc problem or it's not possible. So for incoming segments, we check the following condition here. And the first step is to check the no asset check flag. If the ISS checking for the ghost arc problem is necessary, we continue to the next part of the condition. Here we check whether the arc value is an old arc value before send the acknowledge, because the ghost arc problem only happens at this time. So if it's indeed a old arc value, then we compare the segment's arc value with the server ISIN number. So if it's before the server ISIN, then it's using something the server has never sent. So we should drop the segments and maybe send a challenge arc. Otherwise, the segment should be continued processed. So when the connection is first established, the no asset check flag should be initialized to false. This means the connection needs to be checked for ghost arc problem, because for a newly established connection, sequence number before ISIN can never be used. So once the sender acknowledge satisfy the condition in the second formula, we say that the segment's sequence number is already sufficiently large enough that ghost arc number, a sample arc number can never before the sender acknowledge, can never before the ISIN number. So the checking for ghost arc is not necessary, and we should update the state variable. Next slide, please. So the second implementation choice is requires some RFC 4898 static variable supports. And the static variable here, it tracks the number of bytes that is already acknowledged by the peer. So a TCP stack implements the RFC 4989 specification could use the following condition. Basically, this condition makes sure that a ARC number is only accessible if it's indeed some old ARC number that's acknowledged something that is already acknowledged. So here is an example. Let's say we have a newly established connection where no data is transferred. So the new condition here will constrain the accessible ARC number to only send acknowledge to send next. And all numbers before this are not accessible. Please, next slide. So currently, Linux and FreeBSD has implemented the ghost arc mitigation, and Linux use the second choice. They have implemented the RFC 4898 specification, and FreeBSD has also adopted the input check for ghost arc, and they are using the generic solution, but they have some optimized the conditions in the drafts. So we are planning to also adapt this optimization in the next revision. Next slide, please. We would kindly ask for your suggestions and help to improve and develop the current internet drafts. So we have maybe several options. The first is we might leave this to implementation. And the second is we may add this as an errata for RFC 9293 or RFC 5961. Or we could require the RFC 5961 as a prerequisite. As our discussion with Michael, this could optimize our condition or simplify the internet draft a bit. Or the last choice is maybe we could also make this into a short RFC. So if you have any questions or suggestions, please share with us. Thank you.
Thank you for the presentation. So the question here is, so one of the questions that chairs would like to get feedback on is on the procedural way with how to handle protecting against ghost acts. So should we specify, should we document that? Should we specify that? And if so, how?
Hi, Lars, good that you're asking that and not about like the technical merit, because I don't have any, I haven't read the draft, but it looks really good, right? Don't get me wrong, and it's implemented. So yes, we should definitely do something, and leaving it up to the implementation, I think, is not what we want to do. We want to write down what implementation should be doing. I don't think we can do it as an errata because it's not actually a bug, that like a mistake in the text, right? It's actually adding something new and valuable to the spec. So it needs to be its own RFC that updates whatever needs to be updated. And yeah, we should do this, I think. Whether we want to have that support as a prerequisite, I'll leave as a question to others. Thank you.
Michael Twixen from the floor. Why I brought up the question of should this be in addition to 5961 is that the Linux implementation, which is using this byte count variable, that way extends the check which is described in RFC 5961. So that way is improving the 5961 check. And I don't see why an implementation, I don't see a technical reason why an implementation would like to check for ghost X, but not the check from 5961. The ghost X check only works in the first 2 gigabytes. I choose the term technical reasons because 5961 has IPR declarations on it. And in the BSD implementation, this code is protected by a syscontrol variable, insecure syn, insecure reset, insecure ACK. So if someone does not want to use this IPR, he can turn it off by syscontrol variables. But from a technical point of view, I would say write this write an RFC and harden the condition used in 5961. 5961.
Would Lars, either of you like to summarize the conversation, or is it not relevant to the room? Okay, thanks.
Pardon?
So I looked at the data tracker, and the data tracker does not record any IPR for 5961 as being submitted. And I think the authors are from Cisco, and Cisco has like a general license agreement. And I think if there were IPR from Cisco, we could like work with Cisco. So generally, so we should double check what the status is if there's any other IPR that I'm not aware of. It might not be from the authors, it might be somebody else, right? But the data tracker, at least on my casual clicking the IPR button, didn't come up with anything.
Thanks, Lars. That's helpful. As a chair, do we have a clear idea of how to take this forward? I think we have a number of ways we don't want to take it forward. It seems like there's pretty good consensus that we should do something and not just drop this on the floor. It seems like we cannot do this as an errata. I don't see a ton of interest in doing a separate RFC, although maybe I'm misreading that. Huh? Lars, can you, sorry, I can't hear you. I could update do a BIS on another RFC.
Michael Twixen, as an individual, I would be willing to help on working on the RFC. It's a short document.
Thank you, Michael. So it sounds like maybe there's support for moving this forward. Yoshi, as the other chair, do you have any thoughts on?
Yeah,
how
I
the-
basically agree with creating a short RFC.
Yeah. Sounds good. So based on that, I'm inclined to say we should have a call for adoption on the mailing list after this week. Okay. Great. I think that's all we have for this meeting. Is that?
Yep. Pardon?
Yep.
You found the IPR.
Yeah.
You did or you did not? Okay, so that has been clarified. Any further comments?
So on 5961, Peter Lay, there is IPR declarations on it in the data tracker, so I'm not sure what happened.
Thank you. I mean, I don't know why. We can check offline. Thank you. So 90 minutes were the perfect amount of time for this meeting. We are
Okay.
done, so we can give you. Pardon, Yoshi?
Oh yeah, can I ask some technical question to the draft? It's not a process question, it's technical question. Oh, also has already gone. Okay. Okay. So for the option 2, I think there might be a wrapping issues. I think the byte ax is int 64. So if you receive the data more than 64 bits, the counter has been wrapped, and then it might cause some issue. That's my naive thinking.
To clarify, option 2 is this one. Is that correct?
Yes.
Or
Yeah,
Yes.
that one.
Yes.
Okay,
Yeah. So I think TCP starts is into 64 value, stores in into 64, right? So if you send more than 64-bit bytes, then the counter will be wrapped.
That's
Am
correct.
I not clear enough?
For today, this is a high number, but that's why the BSD implementation is, we use the other one. It's simple to avoid this overflows.
Maybe I should send a message to the mailing list, I guess.
Yeah. Mm. Yes, so our current draft doesn't consider if it's happening to have an overflow to in this problem. So it could happen. Yeah, if it's large enough and it's wrapped around, then this could happen. Yeah.
Any further comments? Then you get 30 minutes back.
Thank you, everyone.
Thank you.